Are you aware that there are trillions upon trillions of those nanorobots inside your cells within your own body that are essential to your cellular functions and to your life? Yes, they are called motor proteins. But is it possible to explain their complexity and their very existence through Darwinian evolutionary mechanisms? Well, this is what we're going to explore today. Peace be upon you all and welcome to a new episode about whether evolution is true or false. Let's start by imagining a small village where there are few houses that are centered around a small square. And each house has its own farm just in its backyard. Well, this small village does not need that much of transportation and roads and traffic laws because, everything is at arm's length. But now imagine a huge metropolis, a big city, where there are industrial zones, spaced for places for waste disposal, you have administrative buildings, you have a command center, you have residential areas, and you have materials coming from outside of the city, exports from the city to other cities, and industrial processes happening inside the city. In such a city, an efficient transportation system is essential. Now let's imagine we are maybe 1,000 years in the future, where artificial intelligence is managing things in a super and hyper efficient way. Now imagine that there are those robotic cars and trucks and robots in this city that will bring in the materials from the outer rim of the city coming inbound, take them to the industrial zones, and then take the products and deliver them to where they are consumed. Now, even consider that there are other robotic vehicles that would collect the garbage and take it to the garbage disposal and recycling places. Now, each of those robotic vehicles will need to be specifically designed for its cargo. Now, assume that this city has millions of inhabitants and a very complicated mesh of roads, but due to the huge advancement of the city, those roads can literally be assembled and decomposed on demand. So if something wants to move from location A to location B, a road is established, a vehicle would arrive to it, directed by artificial intelligence that's suited for this cargo. It will pick up the cargo, deliver it to the target, and then go away to do something else while the road just decomposes into thin air. Will somebody who is coming from our present looking into this future be reasonable if he considers that this system happened through chance, purely random chance, driven by unguided trial and error, not involving any intelligence whatsoever? Then we need to ask the question, during all those iterations and trials and errors, how could the city exist? And if the trial and error happens to happen, how will the city exist to serve the purpose of its existence? Obviously, it will not be a reasonable resolution. Let me surprise you to tell you that your very cells as a human being has a system that is very similar to this hyper-sophisticated and advanced system that I have just talked about. Those are called motor proteins. Those motor proteins come in different families: kinesins, dyneins, myosins, and those have specific functions. They look like robots.
2 feet, it's connected to the body, sometimes they're called 2 heads, connected to the body through neck linkers, and they have a walking motion, just like what you see. And this walking motion moves on those railroads that are automatically assembled from source to destination.
Existence on the kinesin on the starting point of the microtubule will catalyze the extension of the rest of the microtubule. There is a traffic law. Kinesins will move in a certain direction, dyneins in a different direction. But even in recent studies, it was shown that some of those motors can switch gear and change direction. But not all kinesins are born similar. Kinesins can move around something as big as a complete power plant, a mitochondrion. One mitochondrion can be comparable in size to a complete bacterial cell. They would have those adapters that are specific to that kind of cargo that will make the kinesins hands, or what you can call also tails, attached to that specific cargo and drag it along from point A to point B. And then the microtubule will decompose. Now, when you look to those graphics that you have seen, when you look to this specificity of design, the design of the very microtubule, of the very kinesin, the integration with the energy production system that causes the four chemical reactions that happen in succession to produce the motion, the adapter that makes it adapt to its cargo. And then you think, which of which have occurred first? Because if a microtubule exists without its very kinesin that moves on it, then why would the microtubule continue to exist as a transportation system? It can also be used as scaffolding for the cell. But then there are other, simpler kinds of. Moreover, the very existence of the eukaryotic cell depends on the existence of the transportation system. Otherwise, waste materials and products of the cells and incoming materials and outgoing products will not have the transportation system that will move it around. The cell will essentially either die by deprivation or by poisoning. But I will even surprise you. The very existence of the eukaryotic cell is dependent on its successful reproduction, its successful cell division. And the eukaryotic cells are pretty complex. They have the nucleus, they have all this genetic material, and they need to undergo a sophisticated process for cell division. And guess what? This process involves the stretching of those microtubules, attachment to the chromosomal material, to the chromatids, at a specific junction called a kinetochore. And this kinetochore will have what you see in front of you, this tension sensing system that then depends on a signaling system that uses Dynein motors that will pick up that signal when the kinetochore thinks that it is ready, in a ready state, take the signal away, and then the process of cell division can proceed into a successful division of the chromatids. One of the pairs at each side. So the very existence and survival of the eukaryotic cell depends on the existence of the motor proteins themselves. And guess what? If you trace back the motor proteins, the kinesins and dyneins, you cannot trace them all the way back to prokaryotes. You have to stop at a hypothetical being, which is the last eukaryotic common ancestor. So nobody can say that they have happened through billions and billions of years of evolution in prokaryotes. They suddenly appear in eukaryotes. So how can that happen? If eukaryotes happen first, without the motor proteins, they cannot survive. And if the motor proteins happen in the prokaryotes, they have no use because it doesn't need them. That's why, until today, prokaryotes do not have them. So let's try to be reasonable here. Is anybody who would call himself reasonable capable of saying that the existence of those motor proteins in this specified functional design can be a product of randomness, can be the product of the blind, objective-less natural selection process acting on molecular level over random mutations? Random mutations, where just to create one protein, you are much, much worse than looking for a needle in a haystack. You're looking at one functional possibility of a protein in 10 to the 77. I would say it is not reasonable or rational to take these assumptions. What if we are looking for all of those proteins that will create the body of the kinesin, the adapter, and make it attach and work efficiently with the microtubule and its integration with the energy cycle of the cell. Number one, design paradox. And number two, how come it is there starting the last eukaryotic common ancestor while it is not there in prokaryotes? And number three, if the very life and existence and division of the eukaryotes depends on the existence of the motor proteins, which of them was there first? Another chicken and egg paradox. I have interviewed one of the top scientists in the world, top chemists, Dr. James Tour, who is also a brilliant mind when it comes to nanomachines, humanly manufactured and designed nanomachines, and asked him, can this be a product of randomness? And his answer was flat out, no. And you can check my interview with him in the description and in the link. I will leave you with this idea until we meet again to further discuss the challenges to evolution on the molecular level, where we look further into proteins and enzymes. See you on the next live stream. Do not forget to send me your questions so we'd answer them at the earliest. And make sure to look at article number 5 on the course page and on supporting material and at the interview with Dr. James Tour. See you again soon.